at the time.
So I'm going to keep with the same theme, but with a very different outline. In my talk, specialization systems, you'll see, are inevitable, already the norm, and practical. So let's start with the inevitability of specialized systems and specialized operating system. And for that, I'm actually going to use a very simple case study of a key value store. We all know what a key value store does. We all have a sense of what the APIs of a key value store look like. Now, I'm actually going to use one specific key value store, which is the S3 object store at Amazon. So it's quite large. It's actually 2 trillion objects as of a year ago, so it's probably 4 or 5 by now. And if you think about it, there are 2 ways in which you can envision building or using such a key value store. One is you could actually use existing commodities, standardized, generalized building blocks. And you could probably reason about the fact that you can build a key value store that can scale using existing commodity components. As a matter of fact, we actually did that at EPFL. That was a design project for master's students, and they all came up with a solution that actually involved using existing building blocks, abstractions, things they had learned in classes, and a DHT to put it all together and make it look like a scalable system. Of course, that's most likely not what Amazon does. It's most likely not what Google or Microsoft does. As a matter of fact, conservatively, you can imagine that between a brain-dead solution and a specialized solution, there's at least 1 or 2, if not 2 orders of magnitude in price performance. What we learned on Monday from Brad is that not only do you have to use specialized systems, you have to go out of your way, outside of the norm, and obviously Reed Solomon, I learned on Monday, is a very general purpose way of doing erasure encoding, but if you're really serious about large scale, you have an extra special scheme that gives you an extra 14%. So obviously this is a rhetorical question, which would you choose if you had a large problem? So specialization is obviously inevitable if you have a large problem. If it is big, it will be specialized. And that is because infrastructure and systems matter at scale. Now, not everything is as big as the Amazon key value store, you may ask. Now, obviously, if you have a small problem, there's a good answer, which is you just use the cloud. And so the inevitability of having specialized systems is that we are using more and more concentrated data centers and concentrated cloud solutions that actually themselves are built on top of specialized systems. So either you have a big problem and you specialize, or you have a small problem and use somebody else's specialized infrastructure. Now, not only are they inevitable, they're actually already the norm. Going back to Christos' analogy of cooking, right, there's a lot of specialized pans in order to do and to achieve the best possible meal. So here I'm actually going to focus on one particular subset of systems, which is the operating system. And the operating system is a classic example of general purpose Windows. Right, Linux runs everything from a mainframe of the 20th century, and I'm not kidding, to apparently your next toothbrush. I read this week that there's apparently a competitive market to bring Wi-Fi-enabled toothbrushes to the marketplace. And so general purpose operating systems are obviously everywhere, they win. In reality, when you're serious about using an operating system, very often you decide not to use it. And a classic example is everybody who's basically built a database or used a database system knows that you go out of your way to not use the operating system because the operating system provides general purpose mechanisms that are absolutely unsuitable if you're trying to deliver SLAs to transactions. That's not the only example. Obviously, you can use a file system to store your pictures, but if you're serious about storing pictures, the last thing you want to do is to use a file system, at least if you're Facebook and you rebuild something else that is not using an existing file system. There's another classic example in networking. Right? Everybody complains about the fact that TCP/IP-based kernel networking is extremely slow. Well, if you're actually serious about networking and serious about low latency, you just don't use it. Right? You just bypass entirely, either run it in user space or run some other protocol and framework. So those examples of effectively avoiding using the commodity building blocks by bypassing the capability. But you can also bypass it slightly differently by specializing below the operating system. This is called virtualization. A lot of us got a fair amount of mileage out of virtualization. But a hypervisor is nothing more than a specialized operating system that runs a specialized form of a process called a virtual machine. And it has this nice feature that it actually allows you to separate operationally what the infrastructure does versus what the tenant or the consumer actually consumes, which is why virtualization has been foundational to creating these very large-scale specialized data center systems. Now, not only are they inevitable, they're already the norm, they also are incredibly practical, and they're actually becoming more and more practical. And for that, I'm going to actually tie back to the 2 examples I used before, that of the cloud and that of virtualization. So first, virtualization. we actually people started using virtualization in a very simple way, which is to make it go out of the way to make a virtual machine look exactly like a physical server and not change the operational model. The emergence of virtual appliances effectively leverage the observation that it's actually, now you have a container, you can use the container differently and not have to think about that container as if it was a physical server, but actually truly as a virtual appliance. And that is a specialization of the operational model associated with using systems. Now, once you go down the path of a virtual appliance, then you can customize the operating system of that virtual appliance. Because it is a virtual appliance, it's a very different delivery mechanism. You can specialize the appliance for a particular purpose. Once you go down that path, you can take the logic, even the extra step, and say, well, I actually don't even need an operating system per se, because I'm only running one application in that appliance. And there are cases where people have actually removed the OS altogether and run the JVM directly in kernel mode, because if that's the only thing you're doing in the virtual machine, why not, if that's going to give you performance? You can actually take the logic even further and not use a general purpose operating system at all, but actually move down the path of domain-specific operating system. Just like we have domain-specific programming languages and domain-specific accelerators and hardware, we have domain-specific operating system. It's actually becoming a lot more practical to build and deploy a domain-specific operating system. Because of virtualization, they don't have to deal with hardware. And because of virtualization and virtual appliances, they only need to be designed to run a single application as opposed to the universe of all possible application. Which is why we're actually seeing research on emergence and some of the concepts back from the 90s of having library operating systems that expose abstractions directly to application. Now, this is getting more and more practical because we have a new way to consume innovation and to use the cloud. And technology, if you think about it from a deployment perspective, if you think about consumers and customers actually using technology, it's actually difficult if you need to operationalize the technology yourself. But with the cloud, you actually don't have to. Think about an example of an InfiniBand cluster. Who actually wants to go and be, for the first time, deploy a brand new InfiniBand cluster in a shop that has no experience with InfiniBand? The answer is absolutely no one, because it's incredibly complicated and completely different. But if you can actually rent one and not have to deal with the details, this is a way to adopt specialized infrastructure, in this case, a low latency fabric, for a particular job. And the same example applies to FPGAs as well, which are a lot easier to use in the cloud. And my closing comments will be to keep calm.
Thank you.